Because the Trimble X7 is the first laser scanner built for forensic use that has true onboard self-calibration and a lifetime accuracy guarantee, we wanted to take a week and talk about laser scanner calibration. Welcome back to Trimble Forensics Tech Tip Tuesdays. When conducting a forensic mapping or survey of a crash or crime scene, the instruments and methods used will be scrutinized by the courts. Now, part of the scrutiny comes from whether the instrument meets the accuracy specifications outlined in the manufacturer's spec sheet. Now, part of our burden of proof is whether the instrument has been maintained and calibrated within the timelines outlined by the instrument manufacturer in order to maintain those specifications. Things like instrument leveling and tilt compensation, electronics distance measurement, horizontal angle, and vertical angle measurements all need to be periodically compared to a known standard and evaluated as to whether they meet the requirements of the manufacturer. Now, up until now, it's been mandatory to periodically send laser scanners to a repair facility to have their measurements checked against a known standard. This procedure, often specified at an annual interval, is expensive and time-consuming, and for good reason. The laboratory instruments used to calibrate these highly precise scanners is big and expensive, often costing in excess of $220,000 and weighing over 500 pounds. And that's just for a single piece of calibration equipment. The result is an annual calibration cost to you that is often in excess of $4,000, and this cost is incurred year after year, which takes a big chunk out of your budget. Over the course of a few years, the cost of calibration is close to that of the purchase price of the instrument itself. And yet, the question still looms in court. The instrument was calibrated 9 months ago. How do we know that something didn't happen last month to cause the instrument to malfunction on this scene? This leads to additional work at each and every scene to perform additional checks. Now, while these checks are still good practice, wouldn't it just be easier to have a scanner that calibrates itself at each and every scene? And additionally, calibrates itself each time that it's used. And wouldn't it be nice to have that annual calibration cost savings to put back into things like training or to purchase additional equipment? The Trimble X7 is a unique instrument in that no other scanner on the forensic market possesses this feature, the ability to calibrate itself before each and every scan. The big, expensive equipment used to calibrate scanners in a laboratory has been miniaturized by Trimble engineers and placed within the instrument itself. Now, starting with the electronic distance measurement, or EDM, we include a stabilized reference distance inside of the scanner itself. Before every scan is started, a copy of the laser pulse is peeled off and sent across this reference distance. Once across the known distance, changes are made to the intensity of the beam to measure the return values. And this is going to simulate the measurement of items within each scene that have different amounts of reflectivity. The measurement of the internal standard is compared to a known value, and an adjustment is made to make sure that the measurement of your scene is guaranteed to fall within the specifications listed in the datasheet. Now, while this technology is cutting edge, the big advancement is the miniaturization of the internal collimator. A collimator is a piece of optical engineering that takes a diverging beam of light and straightens it out, a little bit like how a laser beam is generated. Now, to generate a laser beam, a light generator emits photons which bounce back and forth between two mirrors until they gain enough power to exit through one of the mirrors in a straight line, rather than being reflected by them. The beam, although very straight, does have some divergence. That laser beam flies through the air and enters a tube with a lens that straightens or collimates the beam divergence. Now, on the other end of the tube is an optical sensor that senses where the beam strikes and compares it to a known place where it should strike. If the instrument is out of alignment, the collimator senses it. This is how optical total stations with angular accuracies of roughly 0.5 millimeter at 100 meters are calibrated. This collimator tube and sensor is what Trimble has been able to miniaturize and include in the base of every X7 laser scanner. When the calibration procedure is started before each scan, the instrument sends laser pulses down into the base where they enter an internal collimator, and the instrument alignment is checked and adjusted. You're carrying a calibration laboratory with you to every scene you and your instrument is going to, and the instrument is checking itself with that equipment before each and every scan, ensuring your data is of the highest integrity. And when you're done, you're exporting a calibration report, showing that the measurements taken were within the tolerances set by the manufacturer, without having to send it off for the expensive and time-consuming process of manufacturer calibration and certification. Now, this helps you meet that burden of proof in court, that your instrument was functioning properly and meeting the accuracy specifications established by the manufacturer. Hopefully that answers some of the questions you may have about how laser scanners are calibrated. Now, if you want a deeper dive into the science of how the X7 works, we're going to leave a link to the white paper down below. Now, if you found this video to be helpful, give us a thumbs up, and don't forget to check out our forensics user forum and online learning platform at the links below. Stay safe, and I'll see you all again next week.